All right. So this paper. Now, if you are very worried about PSLE, please don't be. Okay, I have students whose parents I've spoken with. The kids are so worried about PSLE. So you are thinking of, what if I don't do well? What if I can't score, etc. Now, the thing is, PSLE is just part and parcel of your journey, right, in life. And PSLE is just an assessment for you to go on to the next stage. So you are going to write a new chapter of your life, right now. So you are going to move on to Sec 1. And I can assure you, when you start Sec 1, 1 month into your secondary 1 life, nobody talks about PSLE anymore. Maybe even the first week, nobody talks about it anymore. And it's just like something you have to go through. When you look back, when I look back at my PSLE, I was wondering, why was I like so scared, so worried, So what if I do very well? So what if I don't do well at all? Okay, the most important thing is when I move on to the next stage of my life, I must put in my best, right or not? Okay, so very important for you all to have this mindset. Which secondary school did I go to? Maybe I can share a little bit about myself later, okay? Later. Okay, I will share with you my journey in life, how come I decided to go into teaching, etc. Yeah. Please go and grab your charger. I'm going to start. In fact, I think the MCQ is not really a big problem. Yeah, I was contemplating uploading or not. Will I be distracting your revision if I upload so many videos on my Insta? We have time for Bluecut because today's worksheet is not that difficult. Okay? Yeah. Yeah. Okay, so whether I want to upload, maybe I'll upload some science stuff rather than things that are related to my cat, my fish tank, my shrimp tank, my terrapins. It'll be some science stuff. All right, so look at these questions. If I look at your answers, let's see here. Okay, not much of a problem. So if you look at question 1, this is a stalk of the white flower. You have done this experiment, similar ones probably in P5, right now. So usually your teacher will be using celery. Okay, some teachers will probably go and buy those white carnation and do this experiment. So this is the white carnation, and then they split the stem into 2 parts, right? Immersed in 2 different water, okay, different colored water, and then you will see that this happens, right now. So you can see half of the flower turn red, the other half turn blue. Okay, why? If I ask you to explain why do you see this? Why is it that you see one part being blue, one part being red? Would you know how to explain this? How come it's not like a mix and become purple throughout? Why is it not purple throughout? If I use the purple pen, okay, how come it's not purple here and purple here? Because blue and red, 2 colors, when you mix them together, it should be purple, right? Okay, Delia said because the water carrying tubes are separate. Is it because of that? What do you mean by separate? Okay, you may be asked this question. Don't think that it's not important. How would you answer such that you can get the marks? The water carrying tubes are separate. Not just that, right? They form what kind of tubes? You must know this. Straight tubes, very good. So they are all straight tubes, right? They are individual tubes. That's why this part of the stem being immersed into the red colored water, okay, only absorb this red colored water up, okay, or allow or transport the water up to the leaves. That's why this section of the celery turn red and the other side actually turn blue. Need to know this. They are straight tubes. They are straight individual tubes. Okay. Next. Now, if you make mistake here, I can tell why, okay? Because you forgot this thing you need to do. Water bodies, we know that this is actually liquid state. Water vapor is in what state? Gas state. Very good. Okay, and then what about clouds? What about clouds? Very good. Why is it that clouds, we actually put this as liquid state? What is clouds? What are clouds made of? Yeah, they are tiny water droplets. So if you have made the mistake here, I believe it's because you forgot that clouds are actually tiny water droplets. Okay, so from liquid to gas, that it has got to be A only, right? Liquid to gas. And then from gas to liquid condensation, we only have B. So answer is C. Yes or no? All right. So those of you who got it wrong, I know why you have gotten it wrong. Okay? Because you didn't realize. You didn't realize, okay, clouds are actually liquid. Now, a syringe contains air and some water. Tom blocked the opening of the syringe as shown. His friend Jerry pushed the plunger downwards. So you have air particles here. So if I were to show you exactly how it looks like at the molecular level, air particles has got a lot of spaces between them. So when you push the plunger, what happened is these particles, these gas particles just come closer together, as you can see from the diagram. You all learned this? Did your teacher show you this before? Did, right? Yeah, by right, shouldn't show you, but we realize that it's easier to show students this. Anyway, you're going to learn this in Sec 1, and you must describe how the particles are being arranged inside solid, liquid, and gas. Correct. Never show or Hansel, but now you see it, you understand? Okay, there are a lot of spaces between the gas particles. Okay, so do you see that when you push the plunger down, these particles are just coming closer together? The particles are compressed so that they come closer together. There are a lot of spaces. But if you're talking about solid, if I were to draw solid particles, do you know how they are arranged? They are arranged like this. They are so closely packed. There are no space between the particles. So there's no way you can compress the particles. And then for liquid, they are very close. They are not regularly arranged. My drawing is not so beautiful, but it's fine, yeah? So they are still very close together, very little space between the particles. So you cannot compress liquid also. Clear? Yeah. Yeah, it was like last year. Yes, you will learn in secondary school. And you have to even describe what happens to the particles during melting, during boiling. Yeah. So answer over here. What's your answer here? Plunger did not move, or did it move? It moved, right? It moved downwards as air. Has no definite volume. Okay, answer is A. Any question here? Yashika, you're already reading secondary school textbook. How come you have it? Is it because it's like passed down from siblings? Or you went to buy it? Interesting. Oh, I see. Okay, good. How was it? You type, I'll read later. Now, Joseph placed object T. So this is object T placed on a weighing scale. So when object T is just on a weighing scale with no other things influencing it, it shows 8 units for its mass, right? So after that, he placed a bar magnet 1 cm directly above object T, and the scale showed a reading of 10 units. So it must have been pushing, the magnet must have been pushing object T down. That's why the reading now turned to 8. Turned to 10 from 8. So there is actually an increase in mass due to the push. Now, he flipped the bar magnet over, okay, and then held it 1 cm above T. What would be the new reading on the weighing scale? It has to be 0, isn't it? Okay, because we see repulsion here. So it tells us that object T must be a magnet. So when he turned the bar magnet over, okay, just now was repulsion. Now there will be an attraction. So once attracted, T is no longer touching the weighing scale. It's actually being lifted up. So the weighing scale will show 0 reading. Right. Okay. Question 5, 2 circuits using identical bulbs and batteries in working condition were set up as shown. Okay, so very clearly here, answer should be just circuit A. Can someone explain to me why circuit B will not light up? Why circuit B will not light up? Yeah, Yashika?
Because if you see, right, circuit B, the positive ends of the battery and the negative ends of the battery are connected, so you cannot like light up.
Oh, okay, yeah. So they cancel out each other, something like that, right? Yeah. So if let's say I'm going to add on one thing. If I add one battery here in this arrangement, do you think this circuit will light up? Yes or no? Type into the chat. Will it light up? If I add in one more battery, just 2% answered. Come on. More of you should respond. I'm expecting Yatso, Salman, Jaren, Hansel, everybody to type in the answer. Answer is yes, because one of them will cancel out each other, right? Okay, and the brightness will be the same as this. So the brightness of the bulb, right, will be like this. Okay, is it something that you all have never heard of before? Yeah. Okay. Anyway, they don't test this in PSLE. They don't test this in PSLE. You thought it just doesn't work. Okay, actually, it's just cancelled out. Yeah. When it is the same end. Oh, okay. Yeah. All right. So this will still work. So I just leave it like that. Okay, let's go on to the next one. Do we learn this in Sec 1? You will do a lot of all these in secondary school, playing with the different connections, etc. Now you only learn about the batteries being arranged in series, and then you have the bulbs arranged in parallel and so on, right? So in secondary school, you're going to use a lot more of these electrical components. You're going to use like the resistor to control brightness. You are going to be playing with circuits such that sometimes you can have the bulb being very bright, and then it will go dimmer and dimmer and dimmer, and then brighter and brighter and brighter. So you're going to do all this. Yeah, ammeter, voltmeter will come in. Okay. Yes, you must go. It is very fun. And I hope your teacher brings you to the science lab often. Okay? When you go to the science lab, it will be extremely fun. A lot of activities you can do. Okay, but there are also topics in science where you don't get to go to the science lab at all. It's just theory. So that part can be a little bit boring. Right? So I hope you get a very good science